With division properties of exponents, we're going to look at these in the same manner that we did with multiplying, and that we're going to expand those powers out and then try to build the rules from there. So our target is that we're going to simplify expressions using what's called the quotient exponent and the quotient to power rule. So let's say we have 4 to the 5th power divided by 4 to the 3rd power. These are powers with the same base. So if we were to expand that out, it would look like this. I have 1, 2, 3, 4, 5 fours on top, and then 1, 2, 3, 3 fours on bottom. What can happen is I could cancel them out, the ones that are on top and bottom. So what I'm left with is 2 fours on top and nothing on bottom, so that's like having a 1. So as a result, I'm left with 4 squared. So you are this cute little boy over here, and you are thinking, how are the exponents 5, 3, and 2 related? I have a 5 on top, a 3 on bottom, and I end up with an exponent of a 2. And so the answer is you subtract those, and you probably saw that. 4 to the 5th over 4 to the 3rd is equal to the same thing as 4 to the 5 minus 3rd power. You're subtracting the exponents. This makes sense when you relate it to something similar in multiplying powers with the same base. You added their exponents. With division, you are subtracting their exponents. So that would equal 4 squared. And to kind of sum that up, our conclusion is to divide powers with the same base, you subtract the exponents. Let's practice this a little bit. So let's take y to the 3/4 power and y to the 1/2 power. I am subtracting those exponents, so that's like taking y to the 3/4 minus the 1/2 power. To subtract those fractions, I need the common denominator, so that's going to be 2 over 4. And when I subtract those, I'm left with y to the 1/4 power. Now on this one, the same concept, the same property is going to apply, but I'm going to deal with the a's and then I'm going to deal with the b's. So for the a's, that's going to be -3 minus 5 times b to the 7 minus 2. I subtract my a's and I subtract the b's. I do not join them because they do not have the same base. So for the a's, that's going to end up being -8. For the b's, that's going to end up being 5. And thinking back to what we learned in that very first lesson, a to the -8 power is going to cause it to go to the denominator. I'm going to do the reciprocal of that part of it. So b to the 5th is left on top in the numerator, and a to the 8th is pushed down to the bottom. So my final answer simplified down is b to the 5th over a to the 8th power. Now, dealing with this in scientific notation, here's an example. Honduras had a population of 7.33 times 10 to the 6th power people 1 year. And it had an area of 4.33 times 10 to the 4th square miles. So what was its population density? So you're wanting to see how many people per square mile. So you can set that up as a division property. I'm splitting up the population over the square miles. So to do that, I'm dividing the first factor, 7.33, by 4.33, and to divide those powers with the same base, the 10 to the 6th divided by 10 to the 4th, I subtract those exponents. So let's work this out. Let's do the well, I need a pointer, not a pen. Here we go. 7.33 divided by 4.33. So that gives us 1 point, and we're going to round to the nearest hundred, 69 times 10 to the, and then since I'm dividing 10 to the 6th by 10 to the 4th, I subtract, and I'm left with 10 squared. That first factor is between 1 and 10, so that is correctly in scientific notation. So they have 1.69 people times 10 to the 2nd, which would be times 100. So that would be like having 169 people per square mile. Now, our second rule here is raising a quotient to a power. This is similar to where we had a product to a power. If you'll remember, in the previous lesson, if we had xy to the 3rd power, you applied that exponent to each factor inside there. Something similar is going to be happening with division. So if I were to expand that out, that means I have 3 x over y's as the basis. So x over y times x over y times x over y. When you combine those, that means I have 3 x's on top and 3 y's on bottom. So that would end up being x to the third over y to the third. So likewise, with product to a power, you distribute that exponent. With division, when you raise a quotient to a power, meaning I have division inside the parentheses, that exponent is applied to the top and to the bottom, like you would in distributive property. See this in action here. So I'm going to put the squared on the 4 and on x to the third. So that would be like having 4 squared on top and x to the third squared. So that product down here is being raised to a power. So on top, 4 squared simplifies to be 16. And what we saw last lesson, when you have a power to a power, you multiply those exponents, and so that would be x to the 6th power. When I was an algebra student, I really struggled with this one, and so I would almost always have to expand it out like this. And I would say that means I have 4 to the x over 3 fractions, and then I would multiply across and get 16 over x to the 6th, and then that would reassure me that what I did was correct. Now let's try this one. I have an exponential expression. That negative second power is going to be applied to the top and to the bottom. So on top, that is 3x squared. That whole numerator is raised to the negative second power over 5y to the 4th raised to the negative second power. So on top, I have a product to a power, so that negative 2 exponent goes to each factor, so that's going to be 3 to the negative second power, and then x to the negative 4th power, over 5 to the negative second power, y to the negative 8th power. Think back to our first lesson on negative exponents. What that negative exponent says is that that power is shifted to its reciprocal position. So the top is shifted to the bottom, and the bottom is shifted to the top. And since every factor in here has a negative exponent, I'm flipping the entire fraction over. So on top, I would have 5 squared y to the 8th over 3 squared x to the 4th. Now everything is positive. What changed it from negative to positive was moving it up if it was in the bottom, or moving it down if it started in the top. You may have saw originally here that you were going to need to flip that fraction over, and if you did, that's great. You could flip it at any point in the game as long as you do it before you're calling it simplified. Now my final step is I can evaluate 5 squared and 3 squared. That's not too bad to do. So 25 y to the 8th over 9x to the 4th. And that is my simplified version.